Hello everyone. In this video I'll be explaining the inner workings of the for loop node, including the for each loop as an extra example. We can start by creating a new blueprint that will place in the level. So right click, blueprint class, actor. I'll just call it test because we just use it as a test actor to see the logic run. You can enter it, event graph, and search for each loop or for loop. It doesn't matter. We just need to access the standard macro library. You can double click it. You will have access to the standard macros. It's very important to not touch anything in here. This is an engine macro. We'll make copies of this and modify what we need. So now we can make our own blueprint macro library. We can go back in the content browser, right click, blueprint, blueprint macro library. You'll want to select object and call it BML underscore whatever you want in here. I just call it micro library. You can enter it and save. Now we can go back in standard macros and copy the ones that we want. For this example, we'll want the for each loop, copy and paste in here, and the for loop. Control C, Control V, and you can save. So now we can see what's happening inside this node, starting from the left, following the flow. It has two inputs, the first index and the last index. The first index gets assigned to a local integer, which is basically the equivalent of just creating a local variable inside a function. You just need to assign it a value when inside a macro like this. So what it does is it assigns the first index to the local integer, and then it checks if the local integer is less equal than the last index, which is normal loop behavior. So after that, if it's true, it means that we still need to loop. And what it does is that it goes into a sequence. A sequence, all it does is executes 0 first and then 1 after. So in this case, it loops the body, so it calls the execution, and then it assigns the local integer itself plus 1. So it's increasing the loop counter. And then it does the check again, and our loop continues like that. When the branch is false, all it does is call the completed execution, which means it's just an extra call for when our loop is complete. There's nothing special about that. So following the flow, we see that this assign here is the place where the body actually loops. So the best place to make changes is between these two nodes. As a starter, the simplest thing we can do is make a latent for loop, which means it has a delay. So what we need to do is create a delay node and just connect it as before. But now we need it as an input, so we can just drag the duration in the input pin and call it delay. Makes more sense like that. And make sure to rename the macro to, you could call it latent for loop or for loop with delay. It's a preference. So now we can test the changes. We'll see how a normal for loop works first. You can call the for loop. Let's give it 9 as the last index, so 0 to 9, which means it's going to loop 10 elements. And we can print string like that. And now we can drag the test actor inside the level and play. And you can see all the elements print at once. But now if you use our latent for loop with the same values, 0 to 9, and a delay of 1, we'll see the difference. You can see now that every second it loops. 7, 8, 9. So the problem with this is that it only loops one element at a time, which can get pretty slow. So what if you want to batch the elements that get looped? I'll show you how to do that now. Just create a copy of the latent for loop and call it latent batched for loop. We want a new input, that's an integer. I'll move it above the delay and call it batch. So what we want is a modulo. So you can, from local integer +1, we can grab a modulo and use the batch as the modulo. If you don't know what the modulo does, it's basically just returns a reminder of a division. So in this case, we want to check if this reminder is not equal to 0, which means he has no reminder. And if it's true, we can use this as the entrance point. If it's true, we just do the normal assignment. And if it's false, it means that it's a new batch. So we can just go to the delay and we can save. So now we can call it latent batched for loop and test it out. Last index is 9, and here batch is 0 by default, which is not great. So you wanna make this batch by default 1, because it makes no sense to batch 0 and have as a delay here 1. You can connect it to the print string like before and see the result in game. Make the batch 2 here. So 2 batch, 1 delay, 0 to 9. So you can see the actual change happening. And now when we play, you can see it loops 2 numbers at one time and then waits 1 second for the delay to batch the other numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So now we can create another macro function and achieve a very powerful behavior that I'll showcase now. So we can go back in our micro library and create a copy of the latent for loop and call it manual for loop. We can delete the delay, we can delete the sequence, connect it directly, change this delay to execution and call it continue and connect it directly to assign. So we can decide now when to actually continue the loop. Oh, I made a typo here. Manual for loop. So now I'm gonna showcase you the behavior that we can achieve with that. I just deleted the other nodes. I'm gonna call the manual for loop. So this is very useful for nested behaviors like this, where you have something that is latent and we need to know when he wants to continue, because if you use a normal for loop, it will just call everything at once in the frame and it will give you unspecified behavior, something that won't work. So when this is completed, it means that this entire loop is completed. So now we can continue this loop and we're gonna run it 2 times, so 0 and 1. And you'll see this happening 2 times now. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's it. It ran 2 times with the batched and latent nodes. So now it's time to talk about the for each loops. The only difference that a for each loop has from a normal for loop is that it takes in an array. And instead of checking from the first index and last index, it checks against the length of the array based on loop counter. So I want to show you something here that's pretty interesting. This array index is redundant. I don't know why they put it like this, but it gets assigned the value of the loop counter right before it's used anywhere. So even if you remove this local integer, this assignment, and connect everything to the loop counter, it will still work exactly the same. But we'll keep this as it is, since this is the version the engine uses. So we can notice something pretty interesting, that there's an assignment with a +1, where it increments the loop counter exactly like in the for loop. So it's the same pattern as before. So if you want to make an edit, like add a delay and make it latent, we can literally just do it the same way as we did in the for loop. So just a delay, we connect this to the input, and that's it. Exactly like we did in the for loop. And we can call it Latent ForEachLoop. And we can test it out. Latent ForEachLoop. We can print string it. We can make an array of strings. Let's say hello world and 3 exclamation points. And it has a duration of the delay of 2. And now we can run it. Hello world, 3 exclamation point after 2 seconds. So I just noticed I forgot to rename this to delay, so we're going to do that. Delay. Save. So now I'll give you a practical example of when I actually needed something like this. So I was creating a grid based on for loops. You usually have a for loop, another for loop after, with this is the X and this is the Y. The problem is, if you have a lot of tiles, it tries to run everything in one frame, and you can actually get an infinite loop error, and it will just stop right there. Or you can freeze your entire engine too at the same time, and you just won't get anywhere. So by doing this, you can actually loop the creation of the tiles, for example. So we can batch them and have them on a delay, so it doesn't stutter the engine or freeze it completely. This is a practical example of what I use this for. Even if after I migrated everything to C++ and just you bash them with a runnable thread and added instances with the bashed node. But this is just a practical example of when I was doing it in blueprints. This is an example for blueprint stuff. I hope you enjoyed the video. If you have any questions, leave them in the comment. I'll be sure to reply. Have a good one.